given the equation 2Hg2S solid plus 2H2O liquid, which becomes 4Hg solid plus 2H2S gas plus O2 gas, with the given enthalpy as plus 595.5 kilojoules, we have to calculate the enthalpy change for the reaction HGS plus 1/2 H2S gas plus 1/4 O2 gas, which transforms into 1/2 Ag2S solid plus 1/2 H2O liquid, right? So we need to find ways to relate the given equation with the ending equation, okay, with the second equation, because we need to calculate the same enthalpy change that is already given for the first equation, right? So we need to find ways to transform the given equation into the last equation, right? So the first thing I noticed is that this reactant Ag2S solid on the left side here is given on the right side in the second equation, right? So what I want to do, and also as you can see the H2O is on the right side as well, and here the right side is on the left side, AgS is on the left side, and H2S is on the left side, and O2 gas is on the left side, right? So we need to switch the given equation, switch sides, right? So we're going to do switch sides of the given equation. So then we'll have to switch, right? We will have the reactants become the products, and the products will become reactants, right, so to speak, right? So we will have 4AgS, right? We're just switching sides, switching all the guys from the right to left and all from the left to right, right? So 4AgS plus 2H2S gas plus O2 gas, which produces 2Ag 2S solid plus 2H2O liquid, right? So now it looks similar to the ending equation. The only thing is you have to modify the enthalpy change accordingly, because we switch sides. If you switch sides, you will have to negate the enthalpy change, right? So it will become the negative 595.5 kilojoules. So now, what is there to do to get the resultant equation be equal to the last equation that we need to get to? Right? Notice that there's a coefficient 4, but however in the last equation there's no coefficient 4. So if we simply multiply this whole equation, this equation by 1/4, we will get precisely the last equation that we need to get to, right? Because 1/4 times a 4 is going to be 1. 1/4 times 2 is going to be 1/2 if you simplify. 1/4 times 1 is 1/4. 1/4 times 2 is 1/2 simplified. 1/4 times 2 is 1/2 simplified, right? So we're gonna multiply equation by 1/4, right? And I'm talking about this equation, right? So we will have 4. Now, you might ask, what will happen to the enthalpy change? The enthalpy change will also be multiplied by 1/4, right? So the enthalpy change, the result, and I'm not going to write this out, and you can already tell that this will become the last equation, but I'm just going to work with the enthalpy change. So it's going to be 1/4 multiplied to the negative 595.5, which will give you, your calculator is negative 148.875. But however, be careful, because your original enthalpy change is given as 4 significant figures, so you need to actually round to the nearest tenth, because that will be 4 significant figures, right? So that's going to be what? Negative 148 point, the 7 pushes the 8, right? So it's going to be 0.9 kilojoules. There you go. You found the resultant enthalpy change. Thank you so much for watching. See you in the next video.